Robot mowers are one of the few robots you can buy today that gives us a taste of the robotic future we were promised in the movies. We still don't have robots that can wash and fold our clothes, but if we want to mow the lawn, sweep the floors, or apparently do backflips, there are dozens of options available. I'm not a lawn guy, which should be pretty obvious from the state of my lawn. I don't really enjoy mowing my lawn, it's just another chore to me. So when I started seeing advanced robot mowers like those from Momotion, I couldn't help but see the appeal. In theory, I could gain back a couple of hours a fortnight to spend doing things I actually enjoy, like making these videos for you guys. So I reached out to Momotion about showing off their robot mowers in a video, and to my surprise, they liked the channel and were keen to send me one of their mowers to get acquainted with. Thanks, Momotion. Don't tell anyone, but I already had one sitting in my cart ready to order. I was just waiting for permission. 100% automated lawn mowing is pretty incredible, and if you're time poor and not the kind of person that finds joy in maintaining their lawn, then I'd highly recommend going the robot route. There is one small problem though. It's still not truly 100% automatic, at least not for me. Every week I am forced to open my side gate and let the mower through to the front lawn. I know, all I have to do is open the gate for a couple minutes. I really shouldn't complain. Some people buy a second mower specifically for their front yard, but that seems silly to me. These modern robot mowers have all sorts of features for dealing with multiple lawn zones and navigating between them safely, so it just seems a waste not to use that. So instead of spending 1 minute every week or so opening the gate, I decided to spend way too much time and money building a robotic door for my robotic mower to robotically mow the front lawn. Like any good project, my initial concept was about as simple as it could be. A swinging flap in the fence that the mower can push through. A good old doggy door. Unfortunately, this would also make it possible for the doggy, Polly, to push her way out and take herself for a walk, something she is very prone to doing. So I needed some kind of airlock system, something the robot could transition through, but with no chance of the dog getting through or following the mower through. So I started looking into Tambour Doors, which are kind of the roller door of the furniture world. You know, the ones you see in 1980s kitchens to hide away ugly appliances, or in caravans to keep all your gear contained. My idea was to use a single large tambour door that, with a motor, can cover either the front or the back of a tunnel, but not both at the same time. Meaning Polly can't take herself on an adventure unless she can figure out how to use Home Assistant. With that idea in mind, I set to work. A trip to Hammer Barn reveals you can buy these Bullnose Profiles pre-primed for outdoor use that look like they'd make the perfect slats for our tambour. With those dimensions in hand and a handful more, I fired up Fusion and got designing. This went through a few iterations before I landed on this. I'm using 2 pieces of marine ply for the sides of my tunnel and 3D printed tracks for the slats. On each side, there's a geared stepper motor and a toothed wheel to drive the tambour back and forth. Each slat has this 3D printed, tooth? I'm not sure what to call these things. They screw into the back of the slat and provide something for the wheel to grab onto and push it back and forth. I'm using one of these industrial whisker switches to tell us where the robot is inside the airlock. I made little 3D printed arms that I attached to the mower that'll actuate this switch at the right point in the airlock. Before I started cutting material and printing, I ran off a small scale test section to make sure the mechanical components were all working and making sense. I printed a representation of my slats and the stepper motor mount and tested the whole assembly. I'm going to be using 2 stepper motors, one per side. I've gone with geared stepper motors for the extra torque I'll need to move the weight of the door back and forth, and I'll be running them in parallel. To control my stepper motors, I'm using this fantastic little stepper controller from a fella across the pond in New Zealand called Josh. It's called the PD Stepper, and it's an all-in-one ESP32 stepper controller, absolute position encoder, and USB PD power supply. And it's open source. You just screw it directly into the back of a standard NEMA 17 stepper motor after installing the encoder magnet, and you have yourself a ready-to-go ESP32 equipped servo motor. It's awesome. This video isn't sponsored or anything, but if you need a stepper motor controller with an ESP32 on board, I highly recommend checking these out. I'll put a link in the video description where you can find them below. I cut my slats on my father-in-law's miter saw, thanks Phil, and painted them all with a rattle can. They came pre-primed and treated for outdoor use, so hopefully they hold up well. Only time will tell. I laid out and carefully squared up all the slats and glued this outdoor polyester canvas to the back. This will hold them all together in one flexible piece. I did add some staples as well for a bit of extra security. The first dozen or so slats have the drive teeth things fitted. The door only needs to move about like a quarter of its length, so this is all we need. I made the sides out of some outdoor rated plywood that I cut to size off camera. The tracks are screwed into place using some 3D printed tools to position them perfectly and ensure proper alignment. For this project, I opted to use a mixture of filaments. For the drive teeth and the cogs, I used Prusament PETG. They won't be exposed to much sunlight, and PETG is a more slippery material than a lot of other thermoplastics, so I'm hoping to take advantage of that and reduce friction a little bit. For the components that would be exposed to sunlight, like the tracks, motor mounts, and electronics covers, I use Prusament ASA. ASA is UV stable, but requires a high chamber temperature to print without warping. I used my fantastic Core 1 for this, which has become a bit of a workhorse in my little garage workshop. When it comes to engineering grade higher temperature filaments, it does a much more consistent job than my bamboo printers. I'm really happy with it. Once I was happy with the placement of the tracks and had tested they worked correctly, I took them off again, touched up some paint, and glued and screwed them all back into place. Then I joined the 2 halves with some aluminium strapping and angle to keep it all square, wired the steppers temporarily, and reinstalled my tambour to test everything together. I set everything up on the lawn before committing to the big old hole I'd need to cut in my fence. I wrote some simple ESP Home YAML, got it installed and working, and ran the mower through it a few times to check it worked reliably. Once I was happy with my code and how everything was working, I built a little frame for the airlock against the fence and did my best to level out the surface underneath. This fence already has a little bit of a wobble, and we're planning to replace it in the next couple of years, so I wasn't too worried about it being perfect. Consider this a long-term proof of concept project. If it all works as well as we're hoping, I'll probably build a version with laser cut steel sides that we can build into our new fence. Before we go much further, I'd like to talk about the Luba Mini itself. This little mower is great. I'm a genuine fan. It uses a combination of RTK GPS and 3D vision to navigate, so you don't need to bury a wire or anything to help it navigate around your lawn. You just program it by driving it around the perimeter of the lawn using your phone as a remote controller. It's a surprisingly fun process. It uses 3D vision to spot obstacles and mow around them. So if you have kids or pets, it can mow around toys and objects left on the lawn without any input from you at all. I didn't even need to tell it where our big apple tree is. It just figured it out all on its own. You can schedule mowing to make the whole process completely hands-off, and you can even mow different areas of your lawn at different times or at different intervals. Perfect if, like me, some areas get more sun than others. The Luba Mini even has electronically adjustable cutting height. So if you cut your front lawn at a different length to your back lawn, it can handle that all by itself. The Luba Mini also has 4-wheel drive, making it more suitable for steep lawns like mine. I'm yet to see it get stuck or struggle with any more complex, steep or slippery sections of our yard. Unfortunately, Momotion doesn't have an open framework that allows for easy local integrations into smart home platforms. There is a community integration in Home Assistant by Michael Arthur that uses a workaround to get information and tweak settings, but it's not officially supported. Overall, I love this thing. It's bought me a couple hours a fortnight and I haven't had to think about my lawn in a long time. But I'd like to see Momotion officially support platforms like Home Assistant in some way, or at the very least, provide documentation and some kind of API for community members to build their own. Anyway, back to setting my Luba Mini free. I took a deep breath and cut a big hole in my fence using the laser to make sure it was nice and square, and then installed the airlock itself. Then I just connected the motors, installed the electronics covers, reinstalled the slats, wrote some automations, and got the mower set up to use the airlock. The Luba Mini and other Momotion mowers can be set up with what are called channels. These are just defined routes between mowing zones that the mower will stick to. Essentially, the mower always needs to know how to get back to the charger safely. If it doesn't have channels between zones that ultimately lead back to the charger, it won't be able to find its way home autonomously. All we need to do is make a channel between our backyard and front yard that goes via our airlock. And this is literally as simple as driving it along a route I'd like it to take using my phone as a remote. For now, I'm running the airlock with a USB power bank, but the plan is to use one of these solar panels that people use for trail cams. It just hadn't arrived in time for this project. The ESP Home YAML is super simple. It just waits for the limit switch to be activated, then toggles the door position. I've also got a check in the automation in Home Assistant to only actuate the door if the mower is actually nearby. The community integration I talked about before reports the mower's GPS position in Home Assistant, and we only allow the automation to run when Luba is near the airlock and currently working. Because the Luba Mini has built-in obstacle avoidance, by default, it won't drive into the airlock at all. To get it to drive in at all, we had to disable the obstacle avoidance entirely. My little workaround is to use the Home Assistant integration to disable the obstacle avoidance when the mower is within a few meters of the airlock. Then it's re-enabled when it leaves that zone again. And with a bit more troubleshooting and testing, it works. Overall, I'm pretty pleased with this solution. It looks good, it's not too obtrusive, and has been working pretty reliably. It's nice knowing my little Luba Mini can go about maintaining the front and backyard without any issue, and it means my dream of 100% hands-off lawn mowing is now a reality. So, what did you think of the project? Have you gone the robot mower route? Are you using different robots around the house? Share your thoughts down below. There are absolutely simpler ways to do this, but overcomplication is kind of my thing. And if you like overcomplication, check out my video on my automated greenhouse, or to be frank, any project on the channel. And if you like this project and want to see more along the same lines, then hit subscribe so you don't miss the next one. Thanks a bunch for watching. I'll catch you next time.